Hello, LS students. How are you today? Today we are going to talk about drugs and chemicals affecting synapses. Drugs have been used throughout history and they are common to all societies. People use drugs to fulfill a need or to escape from daily life pressures. All drugs have negative effects on the normal functioning of the nervous system. Moreover, drugs are toxic substances that cause a state of dependency, which is dangerous and leads to a disastrous effect. Characteristics of drug addicts. They show a irresistible desire to obtain the drug, no matter what the cost is. They have the tendency to increase the dose continuously to obtain the desired effect. They show physical and/or psychic dependency. They show physical and psychic symptoms when there is an interruption of the consumption or utilization. The individual's tendency to cause harm, him or herself, and the society as well. Drugs mode of action. Drugs disturb, modify, or alter the biochemical mechanisms of the nervous system. More precisely, drugs affect the normal functioning of the neurotransmitters at the level of the synapses by modifying, eliminating, or prolonging the effect of these neurotransmitters. Let's see the relation between the drug and the neurotransmitter. We have the endogenous neurotransmitter, which is produced inside the body, and the exogenous drug, which is artificially outside the body. The drug could be agonistic if it facilitates, enhances, favors, prolongs, or triggers the function of the neurotransmitter, or it could be antagonistic if it inhibits, prevents, hinders, obstructs, blocks, stops the function of the neurotransmitter. Let's see the mode of action of some drugs, starting with amphetamines. In normal cases, dopamine is released in few amounts and leads to a pleasure and motricity feeling for a limited time. On the other hand, amphetamines facilitate the exocytosis of dopamine, causing an increase in dopamine release and thus an increase in pleasure, motricity, and activity for a longer duration. Mode of action of heroin. When heroin is taken, it slots into receptor sites on the edge of the pain-transmitting nerve cell, causing a reduction in the amount of substance P that gets across the gap. The heroin also slots into receptor sites on the receiving neuron, blocking the substance P that gets through. When heroin or opioid use is discontinued, the pain returns unless that tissue or organ has been repaired. Mode of action of morphine. In normal cases, enkephalin inhibits partially the exocytosis of substance P, which reduces pain. Morphine has similar shape like enkephalin, so it occupies the same receptor, but inhibits completely the exocytosis of substance P, which stops pain. Morphine stays for a long time because there is no specific enzyme to break it down. Let's see what's the effect of cocaine. Without cocaine, dopamine is recaptured by pumps on the presynaptic membrane. However, with cocaine blocks the recapture pump, so dopamine remains in the synaptic cleft, more dopamine continues to be released, and there is summative increase in postsynaptic transmission. The effect on mood. Dopamine is involved in reward pathways and causes enhanced feelings of pleasure, which last longer than normal. Effect on behavior. Feeling of euphoria, increased energy and alertness, highly addictive, and there is an association with depression as body reduces production of own dopamine over time. Mode of action of curer. In some tribes of South America, hunters caught the curer darts, a substance extracted from certain species of vines. If the amount of curer is sufficient, such a dart can result in death. Curer has the same spatial configuration as acetylcholine, thus curer occupies acetylcholine receptors, leading to muscle relaxation or paralysis. Let's see the difference between stimulants such as nicotine, which mimics the action of neurotransmitter acetylcholine, ecstasy, which increases the release and blocks the reuptake of dopamine, and the difference with sedatives such as benzodiazepines, which bind to GABA receptors causing hyperpolarization, or THC or cannabis, which binds to cannabinoid receptors causing hyperpolarization. So let's sum up the agonistic drug effects. Drug increases the synthesis of neurotransmitter molecules or increases the number of neurotransmitter molecules by destroying degrading enzymes, or it increases the release of neurotransmitter molecules from terminal buttons, or it binds to autoreceptors and blocks their inhibitory effect on neurotransmitter release, or it can block the deactivation of the neurotransmitter molecules by blocking degradation of reuptake. And finally, it can bind to the postsynaptic receptors and either activates them or increases the effect on them. However, antagonistic drugs can block the synthesis of neurotransmitter molecules by destroying the synthesizing enzyme, or it can cause the neurotransmitter molecules to leak from the vesicles and be destroyed by degrading enzymes, or it can block the release of the neurotransmitter molecules from the terminal buttons, or it can activate the autoreceptors and inhibit neurotransmitter release, or it can be a receptor blocker such that it can bind to the postsynaptic receptors and blocks the effect of the neurotransmitter. Finally, at the end of this session, hope you have a great day and thank you.